Hey there, back with another video, and this time I'm going to show you how to connect and program the ultrasonic sensor that comes in the kit. Now, I want to use the input of this sensor to turn on an LED, and that requires a bit of extra wiring and programming also. But this sensor has only 4 pins. We have VCC, the sensor power, trigger, echo, and ground. So following those pins, let's see how to connect it. First, hook it up to the breadboard, and we connect power to the positive rail of the breadboard. Next, the ground to the negative rail of the breadboard. Next goes the trigger pin, which is going to be connected to pin 9 on the Arduino, and the echo pin, I'm going to put it on pin 10. We have to share the power and ground. Ground to ground. And next, for the LED, I'm going to connect the negative rail directly onto the negative lead directly onto the negative rail of the breadboard. And when using an LED, we have to use a resistor so we don't burn it. I'm gonna use a 1K resistor, and for controlling it, I'm going to hook it up to pin 13. And just as simple, we have connected our sensor. Now there's 2 different ways to make this work, the sensor and the LED. When it gets to a certain distance, we turn on the LED for a certain period of time. I found 2 ways of doing this. One is, way better than the other, and I'm gonna show you why. Let's go to the coding. Here's the first solution I came up when trying to program this sensor. First, we have to declare the pins where the sensor pin is going to be attached. Trigger pin to pin 9, echo to pin 10, and the LED is going to be attached to pin 13. Then on the variable duration, it's going to store how long the echo pin is high and the distance, how we calculate how close an object is. In the setup, we set the trigger pin to be an output, the echo to be an input, and the LED to be an output. And the serial monitor, we set it to the baud of 9600 to see what's going on in the measures that the sensor is taking. Now in the loop, we first set the trigger pin to low, wait for 10 milliseconds, then we set it to high, wait another 10 milliseconds, and then we set it to low. That's going to send a signal for then our echo pin to capture. This is the variable duration that's going to measure how long the echo pin is going to be high. And the distance variable that's going to store the time, calculate the time the echo pin is high, then multiply by 0.034, that's the speed of sound. And since we're only interested in the time that it takes for the signal to hit the object, we have to divide it by 2, because how long the pin stays high stores the time that takes the signal to hit the object and come back. And we're only interested in the when it hits the object, not the time to take to come back. That's why we have to divide it by 2. Next, we print the distance to our serial monitor, and that's gonna be this variable distance, and then in centimeters. And for turning on the LED, I came up with this piece of code, which there is a big problem with this, depending on how you're gonna use it. If this is the only purpose, then it should be no problem. But if you have more code, then it's definitely gonna be a problem. So I said, if the distance is less or equal than 50, we're gonna set the LED pin high. So basically we're gonna turn the LED on and wait for 10,000 milliseconds, which is equal to 10 seconds. And well, if that doesn't happen, we set the LED pin to low. We turn it off. Now, let me start the serial monitor so you can see in real time the measures that the sensor is taking. And now I'm gonna put my hand on the weight of the sensor so you can see it. We see we have 8 centimeters and the LED turns on. What's the problem with this is this line right here. It's a delay. Now, until this delay is met, is over, the program stops running. So you can see I'm gonna put my hand again, and as you can see, the sensor stops reading, stop working. That's the problem with this code. It's gonna completely stop your program from running. So I had to do some research and ask a good friend ChatGPT for other solution, and this is what it came up. Let's go to this code that I have already set, and let's upload it. All right. Now let's go over it quickly. First, let me close this one. Let's go over it quickly. We said again 3 pin to 9, echo to 10, LED to 13, duration distance. Nothing changes until this point. Now we have to use a function named millis, and in simple terms, what it is a timer. It keeps a record of time, and we have some new terms. Unsigned, it means that it cannot take negative values. We cannot take negative time. And long is going to be a much bigger value. It's going to store a much bigger value than an integer, because in Arduino, times is measured in milliseconds. And let's say you want to measure 1 minute. That's going to be equal to 60,000 milliseconds. All right, and integer is going to overflow quickly, so we have to use this variable that stores a much bigger value than the int variable. And we're going to set a variable LED start time to 0. All right, then we have another variable and that's going to be how long we want the LED to stay on. In this case, I put 15,000 milliseconds, which is equal to 15 seconds. And then a boolean Boolean variable that's going to set the LED by default to false. Right, again, trigger output, echo input, and LED pin output. Now, in the loop code, we want to set, again, the trigger to low, we're going to send the signal, trigger to high, and trigger to low. Then we calculate the distance again, and we print it to the serial monitor. Now, for turning the LED on, again, the same condition. Whenever we get closer or equal than 50 centimeters, we're gonna set the LED to high. We're gonna turn it on, and we set the LED start time variable that was first set to 0 to the function millis. That's going to start counting the time the LED is on, and we're gonna set it to true, so we're gonna turn it on. Now, for this other conditional, if the LED is on and then we start a timer again, and the LED start time, which is going to start counting when the LED was turned on, if this result from this operation is greater than the LED on time, as you can see right here is 15 seconds. If this value from this operation, when the LED first turned on, if that value is greater than the LED on time, 15 seconds, then we're gonna set it to low. So we only want the LED to be on for 15 seconds. And we set it to low and the variable LED on to false. So let me start the serial monitor. And by using this function, we're able to keep our program running. The program doesn't stop waiting for the condition to be met. As you can see, it's taking some measurements, and I'm gonna get in the range, and as you can see, the LED turn on and the program still running. So it's still taking measures and updating in real time. Now I'm gonna put a timer here of 58, 1 minute basically. And what this does is it's going to continue setting the LED start time when we last trigger the condition. As you can see, we keep triggering and it's going to update in real time. So as long as we keep triggering the condition, the LED is going to stay on. As you can see, it's been a while and the LED is still on. Keep triggering, and the sensor is still working and the LED stays on. As you can see, the time stopped and it's been more than 15 minutes and the LED stays on. So I'm gonna let it go too low, turn it off, wait for the 15 seconds to show you how it works. Now we turn on. Now this is definitely a better approach to this solution. I hope you get something good from this video. Now for the purpose that I'm gonna use the ultrasonic sensor is for motion detection. There are some cons when using an ultrasonic sensor, and that's the field, how wide the sensor can detect movement. And let's say if you're coming from an angle or if you're coming from the side, it won't be able to detect you. So for that purpose, when detecting motion, I'm going to use an infrared sensor. and it's going to be a subject for a later video. So thank you for watching and see you on the next one.